Welcome viewers to our series of lectures on machine learning and explainable AI. So far in this series, we came across the taxonomy of XAI, that is explainable AI. So there are four ways, or you can say the categories into which the explainable AI can be divided. To recall, XAI is basically the explainability aspect of AI models that helps us to understand how the AI model or the machine learning model is performing. So far, we have seen the XAI categorization based on the generalization aspect, scope that gives you global and local aspect to view the models from outside abstract level and also from the local individual samples level. Then also we came across the XAI categorization based on stage. So as we have discussed that there are three stages while we are building the model. So first one is the pre-modeling phase. Next one is while the model training is on the progress, and then once the model is trained, that is we call it post-modeling explainability. So in the pre-modeling explainability, it is basically the exploratory data analytics that is being carried out. So in this step, different types of methods are used to understand how the data is, you can say how the trend of the data is, is there any kind of inherent behavior in the data, or you can say how it is distributed, is it following some particular distribution, or is there any kind of missingness that we have to study across and handle accordingly. So some of the pre-processing like results, or you can say the outlier detections, also the analysis that is required for detecting the outlying behavior of the data. So all these things are studied not only in form of the formulations and simple observations, but also we can use the graphs and different types of visualization techniques imparted by XAI in its pre-modeling explainable phase. Then when the model is like the training is ongoing, it is on progress, then also we can use some visualization aspects of explainable AI to see how the model is getting trained. It means that how the the epochs are being executed, that is each iteration how the model is getting trained, what are the weights we are using in each of the phases, how it is getting updated, what is the learning rate, what is the rate at which the the model parameters are getting updated. So all these things we get to know through XAI techniques during the model training. Is the model is getting overtrained or undertrained, or any kind of other outlying aspects that we can observe even during the training phase. We can see all these things during the in-model explainability of XAI. And finally, the post-model explainability is the actual, you can say the XAI utility that is being deployed by the technicians, the computer experts, to see that how the model has got finally trained and what kind of results it is providing, and what is the like aspects, what are the concepts, what are the critical associations, or what kind of properties are there behind this model training that is driving the model to give a certain prediction or a recommendation. Okay. So it can be any kind of machine learning task. So it can be the predictive analytics, it can be the recommendation, the association, or some time prediction, time series prediction. So it could be anything that a machine learning method is capable of. So these are the three stages. So based on the stages, XAI categorization are of pre, post and the in-model training. The last one is XAI categorization based on computation. So there are two ways where we can do it. The first one is the surrogate way and the second one is the permutation way. So in surrogate model, what happens? We start the process using the original model to make the predictions. So whatever the model is there, we originally train it and make it capable to do some kind of predictive analytics, and then later on the same model is preserved and another model, you can say the surrogate model, is used or is employed to train on the predictions of the original model. So this is the concept of surrogate model. So it learns what the features on which the original model has got trained and finally making the predictions. The second one is the permutation. Permutation here, it refers to the changing or permuting of model features. Okay, so we are trying all sort of combinations of features to see which set of features are making the best prediction. And on the basis of these permuted features, we do the analysis and the pre-model analysis and finally the model training, and then we use the predictions provided by the model based on these permuted features. So there are several tools for this during the permutation that is performed, like PDP and ICE plots are one of the very prevalent ones, that is the partial dependency plot and the individual conditional expectation plots. So here in the diagram you can see that if for instance we have two classes, okay, so the two classes, how they are distributed in the data set and how the predictions are driven using the different permuted features. So this can be visualized using the PDP plots to find out that how each and every instance is mapped to a particular class, and what are the training cycles that were there for doing the predictions. How many cycles or how many epochs, iterations have to be carried out for the model to get trained and give the final predictions. Now let's see the model agnostic XAI techniques. So one of the very prevalent technique is SHAP, that is Shapley additive explanations. So this is again you can say a library of XAI, and there are several platforms that supports SHAP, but mostly we will see how Python can be used for executing these libraries. So the first one is SHAP, and it is based on the concept of the Shapley values from the cooperative game theory. So it's a game theoretic aspect, and also it's a model agnostic one, and it supports several types of models, like the tree based model, like we have seen in earlier examples how the decision trees can be formed, and based on each and every features we can have the root node, the parent node, and finally we make the decisions as we reach the leaf nodes. So there could be the tree based, that also is supported by SHAP, the linear models, and also the neural network models. And there are certain visualizations that are supported by SHAP. Some of them are force plots, dependence plots, decision plots, summary plots, and many more plots that we will see shortly. Local explanations are also could be provided by SHAP. So there are some global explanations also possible through SHAP, and some local explanations for the individual samples predictions are also feasible with SHAP. And when it comes to Python, obviously whenever programming platform is taken, first we have to make some installations. So some of the pre-installed modules have to be there to support SHAP execution. So how do we do this? We do this using this command pip install SHAP. So pip is a keyword, install is also a keyword that is supported within Python programming, and then we use the keyword SHAP. So when you are doing pip install SHAP, then it is installing all the necessary modules, sub-modules for SHAP, and so that you can make the use of visualization techniques and formulation and other things that are coded inside SHAP. And this is the icon for SHAP, as you can see on the screen. Next one is Lime. So Lime is another XAI tool just like SHAP, and it gives some more opportunities for the programmer to see the model behavior and all. So the interface is actually a little different, and mostly the functioning of Lime is also almost simple as that of SHAP, and it is also a model agnostic approach. Local explanations are very much supported by Lime, and it supports the tabular data format also. And not only that, you can have the data in form of image or text or numeric. So again, this is one more very widely used library as like that of SHAP, and the installation command line is pip install lime. So these installation codes that you can see is specific to Python programming, and the icon is on the screen. So each of these libraries of XAI, they have their independent documentations. So even if you are just googling out these keywords Lime and SHAP, you will end up to a vast documentation that is a tutorial with the executable codes along with some of the sample outputs. They are given over there. So these are like independent codes written by the programmers, and then they can be embedded within the Python programming environment. So let's see another one. This is ELI5. ELI5 is again a library that is used for model explanation, but at the same time it is also used for understanding the debugging nature of the code or the model if it requires some kind of improvements therein. So again, there are different types of visualizations available inside ELI, and the full form actually is explain me like I am 5. So it gives you very basic information in a very basic understandable form, so that anyone even without the domain specific knowledge can understand the outputs given by ELI 5. Also, like this particular library, it integrates with some of the existing libraries of Python. Like it needs scikit-learn and some other associated libraries that supports machine learning, and the installation code is similar to as we have just seen for Lime and SHAP. It's a pip install ELI 5. So just when you are writing this code and executing, all the modules that is required by ELI 5 execution gets loaded onto your programming platform. Another one is Alibi. Alibi provides the algorithms for machine learning model interpretation that can give you any kind of the XAI categorization that was based on scope, that is local and global explanations. So this makes it very much privileged, as it can be the model agnostic approach, and also at the same time it supports model specific approach. So different types of explanations at the local and global level can be seen through the Alibi library. Its integration requires TensorFlow and Keras library that are existing within the Python. There is Python support for these libraries, just that it needs to be installed once at least on the programming platform. If you are working with the Python Anaconda environment on your laptop, and if you are using the Colab, that is the Google Collaboratory, so in that Colab system, you have to like pip install these libraries every time you are doing the programming, because given the constraint of the storage capacity, the storage space, not all the libraries that you pip install will stay. Even the data sets that you load for doing the data processing and model building, they also tend to kind of vanish once you log out of your Colab account. So given the space constraint, you have to do the loading of the data set and installing the libraries and the integration of the libraries. Like in this case, Alibi, it needs integration with TensorFlow and Keras. So all these libraries have to be loaded every time you are logging into your Colab and doing the processing along with the data set also. But if the Python, you can say the environment or the Anaconda environment, this IDE, if it is local to your computer system, then all these commands and library installations loading, they has to be done once only. Next one is Interpret ML. It is again another open source toolkit that is used for understanding the machine learning models, the working of the machine learning models. It includes the glass box models and the black box explainers. So here again you have the support of the model agnostic approach, along with it can also be used for creating and explaining through visualizations as well as the interactive dashboards. So here the interactive dashboards is a added advantage for the Interpret ML. And it is again integrated well with scikit-learn. So if you are doing any kind of machine learning, that is, you are using some existing models, benchmark models from the scikit-learn library, the Interpret ML can very well make the model, how the model is performing and what are the intricacies of the model functioning and all. It can very well accommodate that and comprehend very easily to the end user. And the installation command line goes as for the others, pip install interpret. Another one is Daleks. Daleks is again a library, XAI library, that is enabled for visualization, understanding and explaining the machine learning models. Now, it was initially developed for R. R is also a programming language, and then since Python is widely prevalent language, or you can say the programming platform, so it was also incorporated for the Python environment also. So now the Python programmers can also use the Daleks library. Again, this library is model agnostic and also it supports the model specific explainers. So here you can see that again libraries and sub methods are there of Daleks, which you can simply load by using the installation command pip install Daleks. Now let's understand a post hoc model agnostic technique in detail. So let's take up SHAP, which is again a very widely used tool of XAI that people use especially in the Python programming environment. So SHAP, once again we have seen what's the full form for it, and we have seen that it is all about the shapely values, and it depends upon the some of the game theoretic concepts, and it does the predictions based on the features, and also helps you to know that how and why a particular set of feature is contributing to the output, whether the contribution is in a positive way or in a negative way. So, how it drives the model output or model prediction is given by the SHAP. Now, the mathematics behind SHAP, how the predictions are explained, is actually approximated by the sum of the shapely values of each of the features. So, here fx is the prediction, and phi I is referring to the shapely values for each of the features from the set of features, you can say. So, here each feature is denoted by I, and phi naught is the best value that is found after, or you can say during the model training is performed. Now, SHAP also provides you the local interpretability and also the global interpretability. Now, when the shapely values are aggregated across many predictions, because the model, the one thing is the model gets trained over a number of epochs. So, therein also you can get several predictions for a particular execution cycle of the model, and also there are many rows, many samples existing in the data set for which you can get the predictions. So, it gives you a kind of view of global as well as the local aspect. Okay, so global in the sense that you have number of entries, number of samples, and you're getting the prediction, and then it can give the average or the estimated behavior of the model. And local in the case that for each of the instance, how the prediction has got evolved, that is also can be easily studied using the SHAP explainability. So, there are different types of plots available, the force plots, dependence plots, and many more to visualize how these individual features are contributing to the predictive analytics imparted by the machine learning model. Now, these are some of the SHAP plots that you can see on the screen. So, the SHAP plots can be in form of bar plots, it can be the waterfall plots, scatter plots, heat map, force plots. Also, you can use the text plots if you have text enriched data, like you have feedbacks for a product, or you sentiments for a particular social media post. Then you can also analyze how the text input and the model that is analyzing the text and giving a certain kind of prediction, say the sentiment prediction or something, those things can be done using the SHAP plots. Some more plots that are associated with the image analysis. So, image plots, if you have an image input, then how the detection of the a particular image for a particular class, say if we have images of all the pets and we want to segregate which is a domestic domestic animals, like which is a cat or a dog or a rabbit. So, this way also the SHAP can give you that if a model is identifying a particular image as say a dog, then why it is doing so. So, the image plots helps you to do this. Then you have decision plot to understand the intricate decision making process of the models, the monitoring plots. Then there are bee swarm plots and many other plots, including some of the plots that helps you to initialize and incorporate other libraries outside Python, like JavaScript libraries for the interactive force plots. Then along with the plots, there are certain data sets also within SHAP that helps you to understand how these data can be loaded. So obviously you can load your own data set, but if you want to use the inbuilt data sets within SHAP, you can take the data sets from inside the SHAP also. So these are some of the data sets like California data sets, diabetes data sets, IMDb data sets, the famous IRIS data set, that is the classic, used as a classic example in many cases. So these data sets you can use from inside SHAP. There are many more things that we have to see of the SHAP library. So we'll see that shortly in our coming lecture. For then, thank you.